4.3 homework assignment. Now we're dealing with hypothesis testing. What you'll see when you look at these questions is that a lot of them just do parts of hypothesis testing. It's not until you get to the last few where we do most of our 4-step process of hypothesis testing. On the midterm, I'm going to ask you to do the 4 steps that I laid out in that video. So I guess the midterm is more like the video and less like the homework. If you look through the homework, you'll see different aspects of those 4 steps. But rarely, not until the end, will you see all or at least most of the 4 steps. Anyways, question 1, all you're doing is setting up your null and alternative hypotheses. So you read through here. It is commonly believed that the mean body temperature is 98.6. You're not convinced. You believe that it is not 98.6. So to be clear here, it's not that you believe that it's less than 98.6 or greater than 98.6. Your claim is just that it's different than 98.6. And maybe with that information, you can figure out your null hypothesis, what symbol is on the left, and then what mathematical symbol is in the middle, and then what number kind of goes on the right. If you look at the video, the null and alternative hypotheses, the way we wrote them will look exactly like what you're going to put in here. It's just with the drop-down menu instead of writing it. And then when you figure out your alternative hypothesis, you can figure out if it's left-tailed, right-tailed, or two-tailed, and just click the appropriate box. And that's it. Then you don't go any further. You're not stating shape, center, spread. You're not drawing a picture. You're not making conclusions. Just null and alternative hypotheses. And if I remember right, question 2 is the same. Let's see. Yeah, here's question 2, same idea. Read through this problem. There's all sorts of extraneous information. They're just trying to mess with you. For what it's worth, on the midterm, I'm not going to do that. I'm going to give you the information that you need and no extra information at all. When you read through this, I can tell you that almost all of this is extra information. Here we go. You can kind of start reading the stuff that's not highlighted. Yeah, cool. The blue catfish is the largest species of North American catfish. I don't care. The current world record is this. That's great. I don't care about that either. This lake, blah, blah, blah. None of that matters. You believe that the mean weight of the fish in this reservoir is greater than, if I'm going to highlight 2 words for you, it's these 2. It's not that you think it's less than. It's not that you think it's different than. You think it's greater than 40 pounds. And I believe that with this little half a sentence here, you can answer everything that you need down here. Everything above, just messing with you. Question 3, you're performing a right-tailed test. So think about what that means. Think about what your alternative hypothesis must have been. And they tell you alpha. Think about how you could have come up with alpha. Right? Understand what that means. And then they want you to tell them the critical value. So that's one of the steps in the picture that we're drawing for the classical method of hypothesis testing. In a lot of people's estimation, that's the hardest step for the picture for the classical method of hypothesis testing. It's finding that critical value. Don't worry too much about the symbol for what they call it, because that's inconsistent in different books. All you got to worry about is what number goes right here. What is your critical value if alpha equals this and you're doing a right-tailed test? And go back to the videos, study the part on critical values. I think you'll see that to answer this question, this is exactly the info that you need. And I believe in question 4, you do it again, except now instead of having a right-tailed test, it looks like I am told the alternative hypothesis is does not equal is the sign in the middle. You might notice it's going to randomly change this, and it looks like on mine it doesn't give me a mu here. Don't let that throw you off. I thought about deleting the problem for that reason, because this should be a mu. You'll see later in the class this can be things other than mu. But right now it has to be mu right here. So pretend this says mu does not equal 67. Mu does not equal some number. Really don't focus on the letter that you see here, the symbol here. Focus on that one. All you're supposed to get out of the alternative hypothesis is that it's a 2-tailed test. And if you know that it's a 2-tailed test and you know alpha, maybe you can figure out your critical values. There'll be 2 of them because it's a 2-tailed test. And what they want you to give them is the positive one. I think you'll find that one of your critical values is positive and one of it's negative, and they want the positive one for the answer. All right, and then questions 5 and 6 is where you kind of go through not quite the whole process, but more of the whole process of hypothesis testing. A few things that are left out here. They tell you the null and alternative hypotheses as opposed to asking you for them. So expect me to ask you for the null and alternative hypotheses. They don't ask you about shape, center, spread. I will. And then you can't actually draw a picture, but they ask you for the things that would go into that picture. And you're like, which picture? The classical method or the p-value method? Well, since they're asking about the critical value in this picture, we know that they have in mind that this is a classical method problem. What I'll say is sketch the appropriate picture for the classical method of hypothesis testing, make sure to include the alpha, the critical value, in your test statistic or something to that effect. At any rate, they give you all this information. You figure out the critical value, the test statistic, and then based on whether or not the test statistic is in the rejection region, which, by the way, they're calling the critical region, same thing. If the test is in the rejection region, then you would reject the null hypothesis. And remember, when we reject the null hypothesis, that means there is sufficient evidence to conclude that the claim is true. So let's see. The sample data support the claim that the population mean is greater. I think it would end up being this guy here. These are a little bit different than the verbiage that we've used in class, but I think that's the only one that is logically equivalent to the way we've said these in class. So worth pointing out, if the test statistic is not in the rejection region, then there is not enough evidence to reject the null hypothesis. We fail to reject the null. This accept the null is just to mess with you. That's never what you select. And let's see, if we fail to reject the null, then there's not enough evidence to say that the claim is true. So there is sufficient evidence now. There is not sufficient evidence to warrant rejection now. There's not sufficient evidence to support the claim. That sounds good. So it's this guy. So really, it's only either one of these two, based on which of these two you choose. And these two guys are just here to kind of mess with you. And then question 6. Question 6 is kind of like question 5. It looks a lot like question 5, but if you look at it really carefully, maybe you'll recognize that it's not a classical value problem, it's a p-value problem. And I know that because they don't ask me for the critical value, they instead ask me for the p-value. And so it doesn't matter, they don't say because, it's easier to point than to talk. The test statistic is in the rejection region. They instead say the p-value is less than alpha. Right, so if your p-value is less than alpha, that's when you reject the null hypothesis so that sample data support the claim is true. Or if your p-value is greater than alpha, then you can't reject the null hypothesis, so there's not sufficient evidence to support the claim. So similar to the last one, it's just the reason why you're making your conclusion is a little different. So to tie these together with the way we'll be doing these in class, this is step 1, null and alternative. Step 2, shape, center, spread. You can get from this information, but they don't explicitly ask you for it here. Step 3, I'll have you draw the picture, and the picture will include these things right here. So these two boxes both correspond with step 3. And then step 4, when I ask you to make your conclusion, it'll always have 3 parts. Why you're doing what you're doing, what that means for the null, and what that means in the context of the problem. And those 3 parts are listed here, here, and here. So these last 3 all correspond with the conclusion that you're making. Last comment. Sample mean is 80.7. It's nice that they call it a sample mean. It's annoying that they use a capital M for that. I don't know why. Maybe whoever wrote this didn't have access to an X bar symbol or something. That's X bar. Don't let the fact that they're calling it a capital M throw you off. Oh, I guess as long as I'm pointing out different notation. I think I said in the videos that sometimes for the alternative hypothesis, instead of saying H1, some books will say HA. That's what they do here. On these problems, they do HA instead of H1. It doesn't matter. It's the alternative hypothesis. Null hypothesis, alternative hypothesis. I believe that's everything I got for this video.